The first plugin I'm going to show you started out really as just a utility or tool. I wanted to speed up and simplify the task of side chaining, keying a compressor to the kick drum to get that nice pumping and breathing sound. Some people don't know how to do it, and others do. Now, regardless of if you find it confusing or easy, pumping has never been as easy as this. Let's take a look at this track I'm working on. I'd really like the synth chords to have some of this pumping. I can just drop this device onto the track, and I'm all set. In fact, I'm going to group my synth, keys, and noise sweeps to have all that stuff go together. Big time changes are pretty obvious, but what about the subtle subdivisions in between? Just like with any sidechain compressor setup, all that smooth, breathy curviness is making it kind of hard to hear what the rhythm actually is. That's why I came up with rhythmic mode. Now, I know you could do this with automation, but the main strength and selling point for Ableton Live is, as the name implies, live performance. With this device, you can dynamically pump your sound in a variety of interesting ways. Something I really wanted to explore was reversing live audio in real time. Let's take a look at the result in a performance. Now, there are many plugins that would help you fake instant reverse audio. For example, convolution reverbs reading a reversed impulse response. But you don't get the same sound, and rhythmically you're limited to the length of that preloaded IR. Let's compare listening to this example. The amplitude envelope sounds right, but I can still hear the words in the correct order, as opposed to an actual reverse. The answer I came up with was recording audio to a buffer whose size could be modified to match the rhythmic values, and simultaneously read that buffer in reverse, creating reverse delays. Now, this plan sounds pretty easy, but it has one major problem. Data is being read from the buffer at the same time data is being written, which means the record heads and the play heads have to cross at some point in the loop. This creates some pretty bad clicking. Every user-created device I found online had this same problem. I solved it by using 2 stereo buffers instead of 1. This lets me read from one while writing to the other, preventing overlap. Once a buffer is full of data, it stops recording. I wanted something that would make harsh and edgy edits and transitions between the tracks in my session, as well as stutter and mangle the individual phrases in each track. Here's a production in Logic that illustrates the final sound I'm trying to achieve. That's cool, but in Logic it's all locked into a static session. What if I could make all that happen live? So let's look at this track I'm working on. It has 3 short loops. Chords, vocals, bass, kick. Now I'm just going to dive right into some settings I have prepared to show you the final result. Nice! So what's actually happening? First, audio is recorded into a buffer, whose length is a selectable rhythmic subdivision. Now we can increase the probability of a stutter. The wide stereo stutter button will make the buffer read different parts of the buffer for the right channel than it did for the left channel. Next, we can select ranges for downsampling and bit crushing, and weight the probability of appearance. Over here we can create rests with an envelope. Which can be sharp and square, or smooth and curved. Now as we can see, this device has been defined as the master device because it was the first to be loaded. It also tells me how many other devices are loaded total. The second time I loaded the plugin onto a track, it initialized as a slave because it detected a master device already existed in the session. All the parameters on the slave operate independently except for the envelope, which will sync to the master, filling the rests the master track leaves to create a Hocket.